In this video we are going to have a look how boards are manufactured in China. I flew to Shenzhen and I visited a company called JLC, and everything starts in their office. But PCB manufacturing actually starts from here, from this big PCB. Or this is not really PCB. Right now this is just the raw material which is used to create PCBs. And this machine, it will cut this big material to smaller panels. So there is some kind of standard size which is used for PCB manufacturing. It's the size what you can see right now. It smooths the edges, all the 4 edges, and also it kind of round the corners. Well, have a look how the corners are now rounded a little bit. There is different techniques how these panels can be created. For example, like this, you can see they can cut multiple materials at once, and they have many different materials. So it really depends what kind of PCB stack up you would like to use in your PCB. They have to use specific materials. This machine will clean the this material. And in this video we will be talking about how to build 4-layer PCB. This PCB what you see in this picture, I cut the edge of the board so you can see what we are going to build. Because we start from the middle of the PCB. Right now we are going to build layer 2 and layer 3. And a little bit later we will be building layer 1 or top layer and the bottom layer. I will tell you when we will be building them. So it has been washed. Now these are heating elements, so it's drying out. And once it is ready, once the material is clean, it can go to the next room. So let's have a look what is inside of the next room. Before we go inside of this room, we have to, wear this special suit, I don't know. And it's because it's clean. And now when I'm watching this video, I see I still have my shoes. We will need to also remove the shoes actually. Right now this was the first time we went to this room, so we didn't know we have to remove also the shoes. There is a little bit of wind to, I guess it's to clean all the dust. Okay, now the material was cleaned and it's coming into this special room. You can see it's all yellow because we will be working with photosensitive materials. So first this photosensitive film is applied on the raw PCB material. Notice right now you can see the copper at the top of the PCB, and when it goes out it's going to have a little bit different color. Okay, because now there is this photosensitive film on the top and also on the bottom of this material. This is just some kind of holder or buffer for PCBs, so they prepare them and now they can be held there for some time before they continue to this next machine. And the next machine is going to do what? Can you guess? The next machine is going to expose the PCB layout on one side of this material. You can see, I think it's using like a UV light or something to bring the motif on this photosensitive layer. Now this is really cool. Watch what is going to happen. Okay, so we flip the PCB and we have to do exactly the same for the other side. So for the bottom layer we have to put that motif. Okay, Now, what is going to be next step? Can you guess? Here are all the PCBs with the exposed photosensitive layer. Now, they remove the protection foil. You can actually see a little bit of the motif, but it has not been developed yet. So in the next step, we are going to develop this PCB layout, basically this motif on the photosensitive layer. So we are on the other side of the room, and we are developing, or these are the machines which are developing the photosensitive layer. Can you guess how it is going to look when it goes out from this line? You will see. I was always very curious to see what's going on, so I always looked through this glass, and but by the end of this line you will always see what is happening. So there are always some spaces in the line where you can see the PCB, and here it is. Okay, so the motif is developed, but you can see the copper is still there. In the next step, again, what is going to happen? I'm really curious if you can guess all the steps what we will go through. So in the next step, we are going to do etching. We are going to remove the copper from the PCB. So everything what is not covered with the photosensitive film is going to be removed, and only the copper under the photosensitive film will stay on the PCB. Again, watch. Here it is. You can see the copper is gone. Okay. You can see the kind of yellowish material, the epoxy material. The next step, we have to clean the photosensitive layer. We have to remove it. So let's have a look. Again, these are the heating elements drying the PCBs, and here they are. You can see the photosensitive layer is removed, and now we have the basic of the PCB. We have the layer 2 and layer 3 of our PCB. It has to go through the automated optical inspection. So this machine will look for possible issues or problems on the PCB. And if something is found, then here is a sorting machine. So basically this machine will know which PCBs are okay, and which PCBs maybe they would like to have a look at and possibly fix. So this is how it looks. If there is some kind of possible problem, or if the automatic optical inspection says something or marks some places, then real engineers or real people will check it. Next step. What is the next step? Can you guess? You will see. Okay. Honestly, I don't know what is this. This looks like maybe like measuring some thickness or something. I don't know. Basically what we are going to do, we are going to build the next layers on our stack up. So before we actually put there the next layers, the copper has to be kind of adjusted. They need to make the copper a little bit rougher, so the other layer will stick better to this PCB. So have a look how the copper change the color. It's kind of like pink, see? and it still continues. I think it still will do something, or also it then has to clean it, or I don't know all the chemical processes. But when it goes out from this line, the color will be very different. Let's go to this next room and let's have a look. So we are in the next room. And notice they have like multiple lines. So when I was actually looking or thinking about what if something happened in one of the lines, do they have to stop everything? No, they have multiple lines. So notice the color of the copper, okay? It's very dark because it's rougher. So this prepreg, this is something what is called prepreg, will stick better on this. And this is the prepreg, okay? So prepreg is the isolation between the layers. So in this case, it is the isolation between the top layer and the layer 1, and the isolation between layer 3 and layer 4. And they have different kind of prepregs because they may have different thickness, for example. This is the copper foil, which we will apply on top and bottom of the PCB. Very cool machine. Notice the copper is actually on top and also on the bottom of the machine. You can see it there. Okay, top and bottom. And now they place the core, layer 2 and layer 3, together with the prepregs on these between these copper layers, between top and bottom. Okay, so this is the top and bottom layer, what they are doing right now. What will be the next step? Can you guess? We have to bake the PCB together. So as you can see, they actually bake a number of pieces at once. PCBs, also PCs. And from here, this part is going to be kind of very automated. So from here, small kind of robot will take it and bring it inside of a huge room with ovens. This is the room with the oven. So these PCBs, what needs to be, what needs to go to oven. You can see them there. They stack many of them together. This big machine will take them all, and it's kind of it's very automated because it's not very, it's super hot here in this room. When I was recording, after like 10 minutes my phone was like thermal shutdown and warning, and you know, I had to go out to cool it down. So as you can see, all the PCBs went to this big oven, and there is also like hydraulic press. So it will heat up, it will make the pressure, and after, I think they say like 8 hours baking and cooling down, the PCBs are ready to go to the next step. So in the next step, they have to, you know, take this apart. So basically, this is what is going to happen. This is still the kind of very automated part of the manufacturing. Okay, so now you will see what will be happening next. they will split these big plates again to be standard panels, because right now there are two panels in one big plate. I don't know what this machine is doing, but this is the machine which is going to split it. See, okay, now we have two panels again. We need to make them a little bit nicer, so it will cut the edges. This machine will cut the edges. And also they have to, round the edges and make them smooth. So again, it's safe to work with these panels. And they have to also build a unique ID inside of this, into this panel, because, we have to know what is inside. I guess this is just cleaning, and then it goes into X-ray. This is very important step, because they have to find the exact position of the PCB motif which is already there, and then based on the exact position they will actually drill special holes, which alignment holes which will then help in the next steps to align the other layers in the PCB and all the drilling and everything.
Okay, perfect.
Now we are preparing for drilling. So you can see there is the unique ID. They apply this aluminum plate on the top. This aluminum plate is going to help, for example, to remove the heat, and it helps with make the drilling more precise. And based on the holes, tooling holes which we made in the previous step, they place these big plates inside of the machines, and then they will just start drilling. Sometimes they use this tape to hold the aluminum down. And I think everyone have already seen all these machines, how they work. I think they can even check the tool, so they pick up the tool, they can check it, and I think they can also clean it. And then they just drill the holes. It was very fascinating to actually see all these machines working. Drilling is time consuming, so they have like a lot of machines for drilling, and you can see it here. It's like, wow. Many machines. I've been in a number of PCB manufacturing companies. I have never seen so many drilling machines. Okay, so once the holes are finished, then the next step is going to be, what do you think? Plating. So basically we have to somehow put the copper inside of the vias, and that's what we are going to do now. This line here It was the longest line what I have ever seen. So it starts here, and watch how long it is, how long these PCBs will just, you know, be handled by machines. So doing the plating, it has a number of steps. I don't know all of them, but I think one of them is first they have to clean the holes, because from the drilling there's still maybe something inside of the holes. They have to do something little bit the epoxy inside of the holes, and then they need to do you know, Electroless plating. So it's kind of chemical process which will put copper inside of the vias on the epoxy. It sticks the copper inside of the vias. This process is slow, and it's kind of, I think it's kind of not easy or something. That's the reason why in the next step they will do different kind of plating. So this is only some kind of preliminary plating which will help us to have the conductive surface everywhere, also inside of the vias. And then in the next step, what is done is electroplating. But for electroplating, we need to have conductive surface everywhere. That's why we have to do first electroless plating. This is still, I think, electroless plating, very long line. There is not much visible. Basically, you know, we are just putting copper on copper and inside of the holes and vias. If someone understands the chemistry, then maybe based on the color of this, they can guess what is happening. Different color. Blue one was nice. Okay, so I think the electroless plating is almost done, and in the next step there will be the electroplating. So let's wait a little bit. I told you this line is super long, and okay, so we are going to start the plating, and when this line will come to the end of the room, then it will actually bend. You will see. I wanted to speed up this process, but the video didn't look very great, so I just kept this on, like, I think it's double speed or something. But it's also this also gives you an idea how big it is. And I think this is the end of the electroless plating, and we are going to do electroplating. So notice the panel is going to be held this way, and it's going to be held by metal clamps. This is how you usually know that there is some kind of electro something happening. my camera moved. Notice all these balls. I think this is the copper which is then used on the PCB. Can you see the balls there? If someone knows exactly what is happening, it would be super cool if you add some comments and maybe timestamps to explain everyone what exactly is happening in this line. Okay, so now basically we are growing thicker layer of the copper on our PCBs. Usually very standard plating thickness is like 20 micrometers. And it's finished. The plating process is finished. There is still many steps to be done. I guess some kind of cleaning or something. Heating up or drying. And this is where the line still continues. So this was the end of the room and the line just bended. And yeah, again, some kind of cleaning before the next step. What do you think, what is going to be the next step? We have already seen this. So in the next step, we have to, again, apply the photosensitive layers and, basically create the PCB on the top of this. If you have more than 4 layers, some of these steps there will basically repeat multiple times. That's why multi-layer PCBs are so expensive. Okay, so as I said, we are going to apply the photosensitive layer on top, bottom of our PCB. Notice the color of the copper. Here it's going to be dark because of the photosensitive layer or photosensitive film. Then we have to again put the motif on the top of the film. So we are basically back in the same room where we were before. The PCB is just coming from the other side. So before it was coming from the, from the other side of the line. And we are using the same machines. I think these are exactly same machines what we used before. We have to flip the PCB and basically draw the tracks and everything again on this bottom layer. And once this is finished, this photosensitive layer will need to be developed. And this is basically the end of the longest line that I have ever seen, but it's only end because I don't know, it's not connected together or something. You may notice actually it could continue by itself. So it could be even longer. But as I said, sometimes they have multiple lines. I just kept thinking, like really, if something gets wrong, what's going to happen? If they can't manufacture, then it must be like very expensive. No, because they have multiple lines and they can use different lines. Now we are on the other side of the room, so we know exactly what is happening. We are developing the photosensitive layer, and I'm very curious if you notice something unusual about this layer, because it's a little bit different from what we were doing before. These layers, they have to be negative. And this is done because there is a trick how to protect the copper which is already inside of the vias. I'm going to explain in the next step, you will see. So from here, what is going to happen? They are going to apply thin layer on this copper, and this thin will protect the vias and the holes when they will be then etching the copper. This is how it will look when it is finished, when the tin is there. But first let's wait, let's see how it is done. So basically this big crane will pick up the PCBs, and there are like many different chemicals, and it will just go through these chemicals, and that's how the thin layer is applied. Big machines. Same machines are also on the other side behind me, and I have no idea why it is so huge. Probably it takes some time, so it has to be really big so they can do many PCBs at once. And this is how it looks when it is finished. Okay, so everything what was copper before, now it's covered with tin. And this tin is protecting all the copper. This tin is covering the copper which we would like to have on our final PCB. After the thin layer is applied, in the next step you can guess what's going to happen. They have to remove the photosensitive layer. Let's see if I guessed correctly. So they are going to remove the photosensitive layer. Basically what we will see will be the tin and copper. Again, a lot of chemicals. Here you can see. I think behind this machine it's better visible. Yeah, see? So copper and tin areas. Tin is protecting the traces which we would like to have on the PCB, and now we are going to remove the copper. The dark places are is the copper on the other layers, okay? But you can very nicely see now there is the epoxy So the copper was removed, all the places with tin were protected, they are still there, and also you can see copper from the other layers which are inside of the PCB. And now we should see our final PCB, or at least the final copper on our PCB. So let's have a look. Here it is. Okay, tin was removed, only what left is the copper which was protected by the tin layer. So these are the traces which we would like to have on the PCB. Again, automated optical inspection. If there are any flagged areas, they will be checked by people. I was very surprised how many checking is actually in this process, and I understand this because if there is something wrong, they have to fix it as soon as possible, because you really don't want to continue making all these processes on, like, you know, wrong PCBs. So a lot of inspection. This is one of the inspections. For example, this is testing, but this is not the final PCB testing. They use these machines only to test maybe some critical PCBs, like maybe with thin traces or very small clearance, or if customers ask to test them in this specific step. And it's because if there is something wrong, again, they don't want to continue all the other processes with wrong PCB. They have to fix it before it goes to the next processes. She's fixing some of the issues. So this is how it looks, okay? Washing the PCBs before the next process. What's going to happen next? Next, we are going to apply the solder mask. Did you guess correctly? I'm curious. Or maybe I was wrong, I don't know. You'll see. But because everything is yellow, I guess it's the solder mask. Again, I don't know exactly what this is doing, this machine. This one is doing nothing. You will see in the next machine how the solder mask is applied. I guess maybe they have different machines because I don't know. Maybe if they use different color or something, they can clean one machine and still use the line. Here you can see how the green solder mask is applied on PCB. It's applied on everything, okay? We still have to develop the mask, openings in the mask. Apply the green color also on the other side of the PCB. If you use different color PCB, you can imagine how much work it is actually change the, you know, all these colors. Now we have to dry this solder mask, so it goes through this big oven. And in the next step, we have to apply the we have to tell where the openings are for the paths. Again, I think UV light or something is used for this. Have a look. You can guess what's going to happen next. Next, we have to do exactly the same also for the other side of the PCB. So we have to flip the PCB on the other side and do the openings in the mask. So it was just exposed. Again, we have to develop the mask layer. So right now it's still, everything is still green. Okay, we still have not developed the openings. And this is really cool because this is my PCB here. Okay, this is the PCB from one of the tutorials I'm working on, and it's super cool to see actually your PCB in this big panel and during the production process. So now they are going to make the openings around the paths. They are going to develop the solder mask. So we are in the next room with all the chemicals and machines again, developing the solder mask. After this is finished, we should be able to see the paths. Oh, this is red PCB. We are very lucky, we can see also different color PCB. Coming out, so there is still green PCB, and here is red PCB. Cool. And now when we have a look, we can see the paths. Okay, next. What's going to happen next? Nice purple PCB. Can you guess? Tell me, what do you think? What's going to happen? 3, 2, 1. Did you guess correctly? We are going to make silkscreen. So in this case, it's going to be the white silkscreen. Big machines. Oh, big machines. So it has to be done on one side of your PCB, and then of course we have to do it also on the other side of the PCB. Now, when you see all these processes, think about your PCB. Like when you would like to design your own highly customized PCB stack-up, customized colors and everything, how complicated then it is for PCB manufacturing. If you stay with standards, what they generally do, you can get a really good price on your PCB because they can integrate the PCB into these like big bulks of PCBs which they are manufactured in thousands. Okay, now you can see there is the white silkscreen on the PCB, and it has to dry in this big oven. Again, I'm going to ask, what do you think was going to be the next step? The next step is surface finish, and in our case we will do gold surface finish. So before everything is going to happen, PCB has to be cleaned, of course. So again, let's clean it. I'm telling you, I have never ever seen so big PCB manufacturing before, and I have been in a number of them. Cleaning PCB, still cleaning, or maybe also doing something, you know, to prepare it for the gold plating. But I guess it's probably only cleaning. Again, if anyone knows more details, leave comments. Okay. Oh, I see. I think there is some kind of foil on the edge of the PCB. Yeah. See? And this is where the gold finish is happening. Notice all the vapor. And have a look. Let's have a look what is inside of this big boxes. Chemicals, a lot of chemicals. I think some of these are like water, or I believe in some of the chemicals there is water on top of them or something like that. I don't exactly know the process, but yeah, definitely this is why the gold finish is so expensive. Green chemical, blue chemical, all the kind of colors. Once this process is finished, so once it goes through multiple chemicals and I guess also some washing or something, then you can see there is gold applied at the top of the parts. Okay, and basically the process of manufacturing the PCB itself, or at least PCB in this big panel, is finished. There are still a couple of steps that are missing. So the next one is, what do you think? After they wash it, optical inspection, of course. So again, have a look if everything is okay. Also do some measurements, you will see. So first it's going to be optical inspection. So this is white PCB. I think we've seen all the kind of colors by now. Purple, red, green, white, even black, I think. So here is the machine for the optical inspection. And this is how they check if everything is okay. If something needs to be fixed or if something needs to be done, then here I think she is checking probably what was marked by the automated optical inspection, and if needed she just put there the arrow or something. I think she's putting there some stickers. Here they measure, I think here they measure the thickness of the gold. And then this is the testing of your PCB. So always when you are ordering PCBs, then you should also order this electrical test. So once your PCB is finished, there are these probes and they will double check all the connections on your PCB if they are connected, and also if there is no short circuit. So this is the final test. This is not the test what we've seen before during the process of the PCB manufacturing. This is the one what you normally select when you are ordering PCBs, and they have many machines, because I guess this process is time consuming. There are also machines behind me on the other side of the room. We are almost finished. One of the last steps, or almost last steps, is to remove your PCB from this big panel. So these machines will do milling. Okay, milling will basically separate your design from this big panel and from all the other designs in the panel. Here you can see on this picture, basically this is also milling around the corners of the PCB. Okay, once this is done, then we simply remove the individual projects from this big panel. Now it's starting to look more like your PCB, correct? Much smaller. It's now much smaller. So if needed, sometimes you would like to do V-score. So these are small lines which will help you to separate the panel from your PCB. Here you can see these kind of lines, okay? This is V-scoring, you can see on the picture. It's from top and also from the bottom, and then you can easily just break it away from your PCB. Often you need this panel, you need these edges around your PCB for board assembly, because you need some kind of space for board assembly, which is and this space is used to hold your PCB during assembly process. This is the last cleaning. Finally the PCB is finished. So it was so many steps, so much more, so much work and a lot of technology. I'm very surprised that now it's possible to actually buy PCBs for quite really good price. Still, if you need like very special PCB customized TechUp and everything, it's going to be expensive. And now I believe you get the idea why, if you need special PCB, why it is expensive, because it's a lot of work. Okay, so once your PCB is finished, everything what needs to be done is to pack everything. So this is the area where your PCB is packed. So if you have ever received your PCBs in this vacuum, packed in this vacuum, I don't know what is it, foil or something, then probably your PCB was exactly here in this machine. If you received this PCB from JLCPCB, then your PCB was exactly in this machine, and this is exactly what happened when they packed your PCBs. Okay, but when we are building boards, this is not the last step. When we are building boards, we would like to also solder components, and they can do it. So this is the stock with the components, and it all starts with finding the right component. Okay, so they will pick up the components, and these components then they need to go to assembly room. Big room, many machines. And this is how it looks. So the components, they need to be placed inside of feeders. Sometimes the tape is very short, so I didn't know this. They can actually extend the tape. So this is exactly what he's doing right now. And this what he's holding is feeder for the components. Each feeder has unique ID. You could see he was scanning the ID for the feeder, and that's basically how they know what kind of components are inside of the feeder. And then these feeders, they are placed inside of the, or they are connected to assembly machine like this. Each feeder holds different component. So when you are ordering assembly in JLCPCB, and if you use special components which are not in feeders, that's why you have to pay extra money, because they have to, you know, place the components inside of the feeder. This is the PCB. This is my PCB, what we are going to assemble. This is stencil, which is used for the paste, solder paste, which is basically the tin to solder the components down. And in the first step, they have to check, or they have to set up the machine for applying the paste. In this machine, they can actually see if the paste is correctly applied over the pads. And in the next step, they have to set up the machine to place the components and also check if the components are placed correctly. This process is again quite time consuming. That's why you have to pay extra for setting up the placement. That's why there is this fixed fee. I think it was like $20 or something for setting up the assembly. So after the assembly, again, there is automated optical inspection. So they take picture of the boards with components placed on the top of the paste, And in this machine, you specify how the correct placement should look. And if anything is different from these pictures, what you taken and what you specified, then it means there is probably some kind of error or something. It can recognize also, you can see it can recognize the orientation of the components, position, everything you can specify. So before the components are soldered, they are double checked if everything is okay. So if everything is okay, it will pass and it can go to the oven. You can see the position of the board inside of the oven, and it takes a couple of minutes to go through this oven. Once the PCB goes out, all the components are soldered, and guess what's going to happen next? We have to double check if everything was correctly soldered. Yeah, sometimes during soldering process maybe component can be moved or I don't know, flipped or something. So there is another automatic optical inspection to double check if everything is soldered correctly, if there are no short circuits between the pads, and all the kind of problem can be checked. Once the board is out of the machine, it will be sorted if there is a problem or if there is no problem. And now this is the complete assembly process. So put PCBs inside of this box or holder or feeder. Then the PCBs are moved to this machine, which will apply the solder paste. Then automatically the PCB goes to the assembly machine. Let's wait a little bit. So it's moved to the assembly machine, first assembly machine. Here in this specific case, all the small components are placed on the PCB. And this is real time, okay? This is the whole process of doing or placing all the components on my board. Now it goes to the second machine. This one is closed because you need special key to open it and they only had one. So in this machine the ESP32 module was placed, big component. Now it goes out. It will go through the inspection process, double check if all the components are correctly placed in solder paste, and then it goes to oven. After a couple of minutes it goes out, all the components are soldered, and then the board goes through the inspection machine again. Okay, it's a lot of work to set up these machines. The assembly process itself is quite fast, but set up everything, it takes some time. And then the board is sorted out based on the results from the inspection. Good board, bad board. There is one more step or process what I would like to cover, and it's 3D printing, because that's also something what JLC can do. And for the board, for my board, I designed this enclosure. And let's have a look how they 3D print and prepare this enclosure. So it was a resin 3D printing. You could see he removed these big chunks, and I think then what he was doing, it was again some kind of curing or something. I don't know exact steps for this process. Here it has to dry, and then still it requires some UV light to completely finish the curing process. This is the box for the PCB what we were manufacturing during this video, and this is a box for the board what we assembled actually. Okay, and everything what needs to be done is some kind of finishing, surface finishing, so maybe sanding, a lot of sanding, different kind of sanding. When you are ordering these 3D prints, you can actually select what kind of finishing you would like to use. And then once everything is done, clean it a little bit, and then double check if everything is okay. These are the finished boxes, 3D printed by different technologies with different materials. They have also this transparent material. It's really cool. I 3D printed a couple of boxes in transparent material. They are really, really cool. And this is how your PCBs from JLC PCB are shipped. So this is exactly what is happening before they ship them. So if you have ever received this blue box, this is how it was packed and where it was packed. That's everything for this video. I really hope you found it useful, and if you would like to learn more about electronics, check out our online courses. You can find their courses about KeyCut, Altium, Cadence. There are courses for beginners and also for professionals about designing boards, PCB layout, EMC testing, measuring, and more. Just go to fedevel.com. Thank you very much for watching, and see you next time. Bye.